So if we travel in our space, we have some initial and final position, and the trajectory of our path is known as the distance or displacement, depending on the path we have traveled. Let's say this is your initial position, and you just displace yourself at this point. Now, this is your displacement, and in physics, you can't travel a path which is shorter than displacement, simply a path which is different than these two, because either you can do a displacement or you can travel, and that's your distance. But let's take an exception in which we are just not traveling in a single dimension, we are traveling in different dimensions, we have different frame of reference. Let's just say you have two-dimensional plane which comes with a y-axis and x-axis. You have two dimensions to travel, like a particle can move any point on the space, and beyond that there is nothing for these guys who are existing in these dimensions, because beyond that I exist. We have to consider that this is the only thing you see, rather there is no depth anywhere. Now let's say we have a observer here at this point which can observe everything in its dimension. It can't just simply look beyond its dimension. It can only see what's around the x-axis and y-axis, meaning that the observer can only detect what is in its dimension, not beyond it, because beyond it nothing exists. Just like us, we can't comprehend what's beyond the third dimension. Now let's just say there's a particle which comes beyond this dimension. Let's say it is somewhere around in the z axis. It comes at this point. As you see, it comes at this point, and then it leaves that point. It just like passes from this plane, and then it comes again and passes from this plane. Let me draw this analogy on the board to understand it clearly. Ignore the mess on my board, I can't wipe it. So let's draw the analogy we just discussed. So I have drawn a plane, like just don't assume its boundaries, okay? I have just drawn a rendered area of it. Like a plane doesn't have a boundary, it is infinite, we know that. So as I said, there is an observer and a traveler is passing from this plane at, let's say, this point. We mark this is the initial point. We'll just say it initial, not naming it as any letter. Let's draw its path. It travels, it passes through this plane, and then it passes from this point to this space, and it comes back again, and it travels at this point. It doesn't necessarily travels, it just marks at points here. Let's say this is the final position of it. This was the initial point where it traveled, and it came from this point. Now we are sure that it has traveled only at this point in the two dimension, and beyond that it haven't traveled anything according to the observer. Let's just analyze what the observer just saw. So the observer sees particle being present at a point, then it disappears, and then it again appears at the point which is in front of this. After a specific time, it appears at this position. So this is what the observer sees. Rest nothing exists for the observer. Now, if we see and think at a point, we'll just say this might be a displacement or distance kind of thing. You'll say that this is a displacement in the two-dimensional plane and distance in, you have traveled the distance in three-dimensional plane. But let me assure you some points which are necessary to consider, that in two-dimensional plane, it's not a distance, because a distance can only be assumed if we have a definite path. Let's say we have 2 points here. So you can use the geometric formula, the distance formula of the graph, and you'll just simply calculate the distance between these 2 points. That is really invalid to calculate the distance between, because there are infinite points present at a plane. So from the two-dimensional frame of reference, we see that a particle is present at this point, and at this point, rest it didn't just exist. So let's evaluate what we just discussed right now about the new type of distance, maybe you say. So first of all, this concept breaks a necessary law of geometry, which is the distance formula. Like when you take the formula and you have 2 points, you can easily take the distance out, the displacement from that formula. Weird to comprehend. You can't just use the formula because there are so many points present, and if you took 2 points which didn't have any specific distance, you can't actually use the formula there, because even maths has a set of rules, not just physics. And I assume the observer because of a necessary thing, which is the frame of reference. Like, to understand from the two-dimensional perspective, I just simply assume there is an observer present there, and it was easier to understand the path. Well, I have also written this in my book. Maybe if you can understand my handwriting, I have written everything about this in depth, because this concept I had imagined way before, like several months before. And maybe I have missed some points which are not valid, but I have written in this book. So if you can understand my handwriting, try to analyze what is there. It's the first page, and these are the rest pages. And there's a final page, not this one, just this page. So yeah, that's it. If you can understand, that's good, because I have included some important points in that paragraph just I wrote for many months before. So you can understand this concept, this new distance, which I call the dimension leap, because it uses two dimensions to travel, and the positions and the path are in different dimensions, like the absence, the splitted path, or any trajectory. 2 points are necessary, the initial point and the final point. Without that, you can't have a proper distance, or you say the path of the traveler, which is called the trajectory. So the trajectory is present in different dimension, which is incomplete, and the points are present in different dimension. So this may seem really invalid, but that's what I had in this concept. I hope this was interesting for you. That's it in this video. Thank you for watching.